Hello to all. I guess you're equipped with your headset. It's all good, you can hear? All good? Okay. A few more seconds to get the people seated and we're gonna start. So hello, I guess you're all equipped with headset. You have a French channel, an English channel. You choose the one you prefer. My accent is probably flexible for the one who want to hear English with a French accent. Few points that we're gonna walk you through today in this presentation, which is focusing on the grid. As much there has been a lot of discussion on energy transition on the generation side in the last 10 years. Probably as well a lot of discussion recently on the demand side and on energy efficiency. That was a big topic at the COP. We wanted to have this session a bit more dedicated to look at the grid itself, which is how do we basically overcome the gridlock, and we start to see that there is tensions in various places. That's true in places in Europe where the grid is at the middle of the energy transition. So what I'm gonna try to walk you through is what will the future of a grid look like. I'm the Executive Vice President of Power System and Services, having spent the last 15 years of my career focusing on large grid, try to understand how they can evolve with digital and wind components inside of the energy transition. The first thing that I want to remind first is what is the grid itself, what is the electricity itself in the energy transition. So you know there is 37 gigaton of energy-related CO2 emission, right? The rest is not energy-related. And inside this 37 gigaton, the grid represents today, so the electricity represents today 13.5 gigaton. So pretty significant, right? 1/3 of the emission. So some may say we need to electrify, and of course we know that electrifying is the solution. But in parallel of electrifying, we need to make sure that we decrease the carbon emission of the electricity chain itself. And of course, what we want to save globally to reach the 1.5 degree scenario, if you were in the sequence with Peter, it's already late, right? We're already somewhere between 1.5 and 2.5. If we want to reach 1.5, we need to save 10 gigaton. So let's translate that into the electricity level. Electricity will need basically to double, but save 3 gigaton of CO2 emission. That's what is needed for the electricity supply to be able to contribute to the decarbonization of the planet. So let's go into what I would call our common powerhouse, because we Schneider Electric are working with a lot of large grid owners in terms of decarbonizing this powerhouse, this electricity powerhouse. And here, if you divide into three components of the grid, you have of course the generation, largely scope 1 for most of the utilities or most of the large grid operator. You have of course the scope of transportation and distribution, a combination of scope 1 and 2 for most of the utilities. And after you've got of course the usage of electricity, which is the domain of prosumer, which is as well the domain where we see the use of electricity increasing, which is the demand side. And we will have the occasion in this session to discuss about how all that is connected together. So the question we should ask ourselves is, are we tackling all those scopes? There has been in the past a lot of focus, I said it, on power generation. That is basically the scope 1 of many utilities throughout the planet. And the initial start of this energy transition journey was focusing on scope 1. A lot has happened. I have to say a lot has happened, and we decided to take here a few examples that we consider are pretty striking of things that are now done to decarbonize the generation. You can look Germany, where basically last year the switch from coal power to more renewable has really decreased the share of coal power with a very significant impact in terms of megaton of CO2 emission. You can look as well some other examples that are more digital related that we got from our Aviva colleagues that have operated digital twin on gas power plant. And you know that in the production of electricity, even in 10 years down the road, there will be gas-fired power plants. So we can improve the efficiency. Of course, the numbers are smaller, but in the energy transition, there's no large victory and small victory. Every drop is counting. That's what Peter was presenting of being impact maker. Being impact maker is touching basically all of the places where we can save. A nice example here on a gas unit that has saved efficiency that is translated immediately in CO2 emission. And the last example is more a reminder to all of us. We know that each time we are able to invest in renewable energy, can be wind or solar, we have an immediate impact on the decarbonization of the power generation, which at large is a scope 1 of many of the utilities company. Now I'm going to drive you to a few different concepts, which is a mix of scope 1 and 2 for customers who are operating grid. The first thing, and you know it, especially if you are in Europe, there has been a strong push from the European legislation to be able to replace SFCs by air technology. What is at stake, which is far to be negligible, is 5 megaton CO2 emission per year, right? Means each time we replace a part of the network with air solution, that's what we contribute to save. And this is a figure at European level, so the figure at world level is of course much more. Another example that can be done, because when you look at your scope 2 into a grid, you have of course the losses from the transmission and distribution through the process. And as much we know that the need of electricity needs to increase, as much is fundamental that to do it in a way that is more efficient. So we went into looking at one example of a grid operator in UK that has combined distribution management system with voltage optimization, and that has been able to reduce the voltage level and then reduce the losses by a significant factor of 15%. Now, if you go look into the Scope 2 report of large utilities, you can go to Iberdrola, Enel, you can go to E.ON, you will see that reducing the losses of 15% is pretty significant in terms of emission reduction. The last area that I wanted to touch on this slide, again an area related to scope 2 of the grid. When you operate a large grid, you've got large workforce, and sometimes you've got large capex investment. What we have assessed with many utilities is when you use an advanced asset management approach powered by AI, you are really able to reduce your OPEX expenses. And what we know is that each time you reduce your OPEX expenses, this is directly translated into reduction of emission, because this is less travel for our people, less calendar-based maintenance, more maintenance based on real data, and that makes much more efficiency into the management of a large grid. Last but not least, I want to look at the demand side as well, because we believe that the operators of large grid, and we will come on that later, operators of large grid need absolutely to connect with the demand. The big challenge that is in front of us for the next 10 years is to multiply by 2 the usage of electricity at the demand side. In order to do that in the responsible manner, connecting the distribution side with the demand side is absolutely fundamental. So that's really here a few examples on which we have seen utilities throughout the planet connecting information from what happened at the demand side to be able to maximize the usage of decentralized generation. You have here a nice example in Australia. Of course, the date can be seen as a joke, but it was on December 31, 2023. But that shows us that the future is starting to be there, where they are during one day, the rooftop production on photovoltaic panel to be able to meet the entire demand of a utility in a country, right? Of course, a sunny day, okay, which in Australia is in December. But interesting to see that with optimization and a lot of digital optimization at the endpoint, one utility has been able to use the absolute complete production of solar panel in an optimized manner and being able to supply the demand this day. Another interesting example is that we see many utilities forecasting that with the right investment in software capability, so it's basically tools that we call distribution management system and distributed energy resource management. When you have those two bricks that are combined, you can really decrease your level of capex investment into the grid, or you can supply more power during the entire day of a given utility. So by doing so, you flexibilize your grid, you connect the demand and the supply, you reduce your level of investment, or if you prefer, you increase your output on a given day. So in this journey where there is an incredible pressure on all grid providers to reinforce the grid, to double the amount of electricity, doing flexibility at the demand side is absolutely fundamental. How all those examples on scope 1, scope 2, scope 3, how are they made of? And you see here the illustration, all those examples that can have very different intent at the beginning are all having a common point, which is a solid data hub where you position data and you orchestrate your data, and this becomes a new battle, I believe, for utilities to be able to orchestrate their grid and manage data. And in parallel of that, some digital innovations, either software, either at IoT level, that allow to capture the right data at the right moment, exchanging those data and orchestrating those data. When you have this strategy, you can look at your scope 1. Of course, with digital, you can integrate much faster renewable, but you can as well be more efficient in your traditional power generation. If you look at scope 2, I give example, you can optimize your network, you can optimize your workforce, you can optimize your asset management strategy. And then, of course, if you have the right digital and the right data strategy, you can exchange with your big consumer and with your small consumer. And you can aggregate demand and you can really build a story of flexibility. And I've illustrated that with a portfolio of offers that we can provide a Schneider Electric in the various domains that are all converging around one interesting software that is called the PI system, which is basically the contextual data repository for utilities to be able to take data from their own operation and exchange as well with data from the external environment. In the plenary, Peter was saying that we work for open software, and that's really the way we are driving this strategy so that those software can exchange together. Now it's my pleasure to call on stage, because I don't want to be the only one speaking, and I think it's much better when our customers are speaking. I'm very honored to have on stage Carlos. Please join me on stage.
Thank you, Fred.
Carlos is CTO of Smart Solutions at Iberdrola, a very famous utility that is, I think, has been historically driving the way on the energy transition, on renewable integration. Carlos, I leave you the floor, and I will be back with you for a few questions.
Okay. Thank you very much, Fred. You can hear me perfectly? Okay, good. And thank you, Schneider, for inviting Iberdrola to come to this amazing innovation summit. And I'm particularly happy because I heard before Peter and now you talking about many things quite similar to the mission and the vision we have in Iberdrola right now. We have been working in the energy transition from the company since more than 20 years. That is our main focus. Okay, it is true that the company is older than that. Before there was a lot of people talking about how old the company were. Ours is more than 100 years old, some of the others. But the reality is that for more than 20 years we have been focusing on this energy transition, okay? And I want to talk a little bit, I mean, most of you will know about Iberdrola, but I just want to highlight some figures, where we are right now. We have more than 62 gigawatts of installed capacity, from where more than 40 gigawatts are coming from renewable assets. It is true that some part of the thermal assets are still necessary, but the future, the vision we have is going closer to 100,000 megawatts of renewable capacity in the future. We have more than 34 million supply points around the world, with more than 1 million kilometers of power lines, thanks to our networks division. We were talking about CO2 savings before. Fred was talking about that. In our case, last year, we helped saving more than 26 million tons of CO2 during that year. And in terms of investments, and Iberdrola, as I said, is working a lot from a long time ago. The current strategic plan is investing more than 41,000 euros in this energy transition between the 2023 and the 2026 years. And doing this all around the globe with the vision of being leaders in renewables, networks, and customers' electrification, okay? Because these are the three main businesses we have in Iberdrola, okay? It's starting the renewable, it is improving and growing our portfolio of assets with the main focus in solar, wind, and storage. Of course, we have networks because that is the way we can deliver that energy to our customers. That is the main objective, not only investing and constructing, it is being able to deliver that green energy for them. And looking ways to help these customers find the best possible solution to electrify their consumption with hydrogen solutions, with electrification of industrial heat, or building one of the biggest public charging networks for the EVs. And if you go into buildings through our smart solution divisions, I mean, helping our customers or helping you to go into EV, to go into heat pumps, and to go into solar and batteries, okay? And I want to catch up with something that Fred was mentioning before, which is what is present, future, I'm not really sure how to say, demand flexibility, which is going to be key. And in fact, this is already something that is key. It's going to help us decarbonize our customers. It's going to help us improve the penetration of renewables into the system. But we can talk about that a little bit later. I want to stop a little bit on how we help our customers, because we find different segments. We have domestic customers, we have C&I customers, big and small. Of course, we have different needs coming from them. Some of them are more sophisticated, some others not. Okay, so we have to find out ways to help them, and this is something that is pretty obvious. We start working on recommendations, letting them know how they consume, what is the disaggregation of their consumption, or helping them monitor in real time what is happening, so they can understand if there's a failure on their consumption and there's an action they have to take. But something that is important in this today is that we give them recommendations, but the action, the responsibility to do something is on their side, it's on your side, okay? And it's something, as I was mentioning before, you can go into PV, you can go into solar and batteries, or you can go into whatever kind of electrification. What is coming tomorrow is something that is possible thanks to these new devices that we are starting to deploy. because of three characteristics I always like to talk is about their size, how big they are compared to the current consumption in most of our customers. Second is how manageable they are. I mean, you can take a lot of decisions on when to charge or discharge the battery, charge your car, and so on, okay? And of course, the connectivity, which is key. And with all of that, we can start building services for the future customers that allow them to control remotely what is happening. But not only them, it is us as a retailer having the responsibility and changing what I was telling you before, taking from the retailer perspective the action to change how these devices are going to consume. So we look for energy efficiencies in every house, in every building, in every industry from our customers. It is not only optimizing, it's also including that flexibility I was mentioning before to provide services to the grid and to the customer itself, okay?
Achieving a more efficient use of energy and taking care of the planet. This is what the Advanced Smart Assistant does. The new smart solution by Iberdrola. How does it work? It's really simple. First of all, you enter the appliances, your habits, and your usage and comfort needs on the app. Second, the assistant's artificial intelligence takes care of everything, adjusting and switching your electrical devices on or off. Third, the Advanced Smart Assistant offers you increased efficiency and bigger savings on your bills, prioritizing the use of renewables and reducing CO2 emissions. In short, more digitization, bigger savings on your bills, and more environmentally friendly. Iberdrola.
So these home energy management systems are going to be key for residential customers. Peter was talking about this before as well. It is being able to use artificial intelligence to autonomously decide when the car should be charged, or how to maximize the use of your solar production, or taking into account the thermal inertia of the house, look for the best moments to heat or cool the house and heat the water. But this is not only happening in residential customers. We have also opportunities for bigger customers in industries, for example, where Iberdrola and Schneider are partnering to build microgrids as a service that is including, or that are including the batteries, the solar panels, and the energy management service, okay? And each company is putting the best from their side as a way to create the most valuable proposition to the customers. And some of those values may be very obvious, like maximizing self-consumption, but then you have a lot of hidden opportunities around peak saving, or trying to optimize your energy management, taking into account your time of use tariff, or of course using the flexibility to improve your incomes thanks to the grid, and allow as well building more resilient while reducing your CO2 emissions, okay?
Thank you, sir. I think it was great to introduce the way practically the solutions can help to decarbonize. I really would like to bring you to one topic that is pretty obvious for utilities, right? Yes. But on which there is a lot of literature, right? Mm-hmm. What you read today in newspaper is that there is gigawatt of solar, of winds that are not connected to the network. What I'd like to understand from your perspective at Iberdrola is what you are doing to facilitate the speed of integration of renewable on the network.
Yes. So, I mean, it is true that there's a lot to be done yet. I mean, we have accomplished, not only in Spain, but in Europe, figures that are amazing, like already surpassing thermal generation thanks to the wind and solar. Really depends on the country. I would say that Spain is not having great problems in terms of transport. Where I see a lot is a problem in the short term someone was mentioning that before in the previous conversation around the customer, which is how can we facilitate better electrification of our customers. Again, it is investing in renewables, being able to set that energy to our customers, thanks to the grid. But in this case, customers are going to have a key role in facilitating that penetration. We are seeing already, and I think that is not always used at the very best possibility. There's a lot of impact right now in the power markets because of the renewable penetration. We are seeing around Europe during long periods prices very, very low. In North Europe, we have seen negative prices, very low negative prices in the previous year, reaching like minus 200 euros per megawatt. In Spain, for example, we had this week, the first day that we had negative prices. It was 0.1 negative, not very low, but interesting enough to understand that there's going to be a lot of opportunities around flexibility. The power markets should be the first way we find possibilities coming from the demand to extract that flexibility. Finding a way we can adapt the profile from our customers so we can deliver them cheaper energy coming from the renewable assets. So at the same time, we are facilitating that introduction into the grid, okay?
Yeah, so you don't see any technology problem, basically. The technology is there. The question is more the dynamic that exists between companies, right?
Yeah, I would say that from a technology perspective, there's no kind of a problem. If we focus on the customer side, I will say that technology's issue will be regarding partnerships between parties in this problem. It is not an issue from the retailer and the customer. Here, there are a lot of different players starting to have a word. We have car manufacturers. We have companies like yourselves as well. We have HVAC system manufacturers. There is a lot of different companies that are going to take part of this situation. And the thing is that we want, as a retailer, to find ways to do this from a customer's perspective, to change how they consume, to change how all these devices are being used. But to succeed on that, again, the conversation doesn't limit just to the retailer and the customer. We need to involve a lot of different companies that are playing into this. I won't say it is a great business in terms of money. That is one of my concerns when talking about this with other different companies. I will say the effort we have to put from all of these different companies is trying to assess this problem we have, which is growing on renewables and doing that in an easier way without impacting the grid so much, thanks to the flexibility in the demand, for example.
Yeah, I'd like to drive you a bit to the industry side, right?
Yes.
To your customers who are industries. What we used to read when we read the report from the International Agency of Energy is that in industry, 78% of the processes are not electrified today, right? So there is a big stake to electrify that in the next 10 years.
Exactly.
Anything that we should do, that you think we should do differently now, both us, means technology provider, utilities, how can we drive force to really transform that in the next 10 years?
Let's say when we are talking with customers, I mean, they have, and I would say that we share this, they have a clear vision. They want to go into electrification. But decisions in this case are not so easily made. When trying to promote microgrid, for example, this is a conversation that is taking long. But it's not only that, it is a situation, for example, when trying to electrify heating and cooling, where we see problems, for example, in the very small grid capacity in that distribution area, that limits sometimes the capacity to do that electrification. And I would say that's You were asking me before if the technology has to do something. Is there any possibility over there, problems around that? I will say, yes, for example, microgrids and the thing we are working together should be an opportunity, one opportunity, there may be multiple ones, but an opportunity to find ways that our customers can electrify in an easier way without impacting the grid. Sometimes they cannot go into EV mobility because they cannot ask the distributor for more power. Batteries storage and intelligence management can provide solutions to help them go into this.
Yeah. I've got a last question.
Yeah.
And this one is maybe a bit uncomfortable for you and for me. In March 4, there was 27 ministers of energy from all Europe that gathered and were discussing about flexibility, right? And they were discussing about the regulations, the legislation. Any message from your side for these people where the legislation could facilitate the mission we have to basically build this world of tomorrow?
Yes, it's not an easy question, because at the same time when we are asking them to regulate and facilitate flexibility, we have at the same time a competence on the other side, and which is also part of our business, which is the rest of the generation. I mean, you can have flexibility coming from the demand and coming from generation. The thing is, are they comparable in terms of costs? I will say we cannot ask regulators to provide bigger incentives to the demand compared to some other technologies. We have to find out a clear field that makes competence proper. So I will say I will translate that question into our own possibilities, from a company that is selling services and a company that is creating products, in finding the way we can extract this flexibility in a competitive way that will, again, compete without any problem with other technologies that are already in the market giving this kind of services to the grid.
Makes a lot of sense. Makes a lot of sense. Is doing this transformation. We know flexibility is essential in the grid of tomorrow, but finding a way to make it competitive and basically that the regulation favors the things that bring competitiveness to companies, to the users, and to companies. Of course, I want really to thank you, Carlos, for having spent time sharing your experience. I think that's great because it allows us to drive into this world of the future. Thank you very much.